the motor, one way to make a magnetic pole. So if you can imagine, I can turn this into an electromagnet, and from a control system, I can send it a signal to energize. And then I can pull that rotor to that pole. Then I can, from my control system, send a signal to the next pole. Magnetize that and draw it to the next one. That's the concept behind a stepper motor. So I'm just drawing that rotor to each magnetic pole. Has nothing to do with the 60 Hz signal in the power lines. So with this concept, if I have a control system that can move these magnetic poles around fast enough, I can turn this thing at 10,000 RPMs. As fast as I want it to go or as slow as I want it to go. That's the idea behind a stepper motor or a switch reluctance motor. And a classic example of that is by Dyson. You know, the guy who makes the $500 vacuum cleaners? So Dyson has used this switch reluctance motor to his advantage, because in a vacuum cleaner, it's an advantage that I can spin that motor at 10,000 RPMs, right, to make a lot of suction for the vacuum cleaner. Have you ever gone into a bathroom and used what's called an air knife? You put your hands in this thing, it almost feels like it's a knife of air. There's a switch reluctance motor in that. He's spinning that air at 10,000 RPMs, and that's what's creating that air knife. So Dyson is the guy who's really commercialized this technology of a switch reluctance